Hi, Graham Roberts here. Well, this little tutorial is really about how to find a rule for predicting the occurrence of something. In probability, we really can't tell the probability or chance until we know the number of possible outcomes and what we call the solution space and so on. I'm not going to go into all of that here. I want to look at a particular question. Now, this question is: a box contains balls that are numbered from 1 to 6. I pick up a ball 5 times and put it back in the box each time. I find the sum of the 5 balls that I picked. How many different possible results do I have? Right, so imagine this box has got a number of balls that you do not know the number of. Right, so there might be 1,000,000 balls inside this box. There might be just 10, but there's a number of them. It doesn't matter how many there are. A box contains balls numbered from 1 to 6. So if you pick a ball up, it's got a number of 1, or of 2, or of 3, or of 4, or of 5, or of 6. If you pick it up 5 times and you put it back in the box each time, then each time you pick up a ball to add to the total, nothing will have changed in terms of the chance of picking up a particular numbered ball because you put them back in. So how many different possible results can one have? Well, the first thing one does is really investigate. Now let's do it with fewer picks. The maximum number on the balls is B. I'm going to call it B, and we're going to say that the maximum number is 6 because that's what the question is about. And for this table, we say number of picks is 1. Now the minimum sum that we can get is indeed 6 because we can pick up 1 6 times. The maximum sum is also 6 because we can pick up 1 6 times. And so the actual different number of results we can have is 6. Now if we pick up twice and put back, then the minimum sum is 2 because that's 6 times 1. If we pick up a value ball 1 and then pick it up again, then it's a minimum sum of 2. But what if we pick up the ball that's got a value of 6 and we pick it up twice? Well, then the maximum sum will be 12, which of course is 2 times 6. If we pick up 3 times, then the minimum number will be 3 and the maximum number will be 18. So you should be able to see a pattern here. 6 times 3 is 18. And here we've got 6 times 4, and 24 is in the maximum sum. The minimum sum is 4 because if you pick it up 4 times, you're going to get 4 if each time the value is the smallest number, which is 1. Similarly, if we pick up 5 times, remember the question was saying we pick it up 5 times, then we know that the minimum we can get is 5 times 1, which is 5, and the maximum we can get is 30. Let's go back to let's go over to this column here, the actual number, the hash represents number of different results. Well, we said that you can have 6 different results if we've got 1 pickup and put back. If we've got 2, I'm saying there's 11. The reason there's 11 is because the maximum number we can have is 12, but we cannot get a minimum value of 1 because the minimum value is 2. So it's 12 less 1, and that's 11. Similarly, when you pick up 3 times and replace, it's going to be 16 because it's 18 minus 3 plus 1. It's 18 less 3 because 3 is the minimum sum, which is also of course the number of picks, but less 1 because the minimum number is less 2, sorry, the minimum number is minimum sum is 3. So you've got to take away 2 from 18. Since in this case you can't have a 1 or a 2 being the sum of the balls. For the number picks 4, we actually just have 24, take away 4 and add 1, which gives us 21. This is because we cannot have a total of 1, 2 or 3, since the minimum sum is 4. And for 5 picks, the minimum sum we said was 5, and we know the maximum sum is 30. We cannot see 1, 2, 3 or 4 as summations, and so we will have 30 minus 5 plus 1, which is 26. The plus and the minus come about because the number of picks is mapped to the minimum sum. So we can notice a pattern that the hash, or the actual number of different results, is a product of the number of picks made, P, and the highest number on the balls in the box, B, less the number of picks plus 1. That is to say, actual hash of different results equals P times B minus P subtracted by 1 is equal to P times B minus P plus 1. So if for 6 picks the number of results will be 6 times 6 minus 6 plus 1, which is 31. Now that wasn't the question. The question asked us what the number would be for 5 picks with a maximum number on the balls of 6, and the answer thus is 26. But bear in mind that if this was for 6, it should be 31, and you can work that one out for yourself. So the conclusion is, for any question like this, we have a rule or a rubric. The number of results will be the product of the highest ball number and the number of picks less the number of picks plus 1. Now that formula sounds very difficult to understand when you first read it or see it. Mathematics is really pattern finding, pattern research, and the art of mathematics is to be able to research and find patterns. What we try to do to live in the real world and make them practical and applied is to try and make it into a form, the patterns that is, into a form that we can actually compute or do arithmetic on. And that's why I was playing with algebra, the P's and B's. So mathematics is about finding patterns. Arithmetic is just a computation.